So let's look at how we would make red light, green light, for starters anyways. So we need a field to play on, obviously, of some type. So I'm just going to quickly make a plane, stick it over here, and we'll scale it up, maybe 3 by 8. So now we have our our ground anyways, right? And you can paint this any way you want. I'm not going to worry too much about the graphics on this. So we more or less need an endpoint. Let's make a cube. That's going to represent our statue that says the red light, green light thing. And we're also going to need the AI. So the way I would run this is we need something. So there is a character. He's in the wrong render pipeline, so let's fix that real quick. Let's just grab all those and go back to standard. There we go. Oh, he's got a little smoothness to him. Looks kind of funny on that guy. So I'm going to fix that because it's funny looking. Go over to the characters. I want to go to my model and bring this back down. There we go. Now he's blocky again. Alright, so if he's a character and we want him to walk and go over here, animation wise, what do we need? Alright, so let's gather our stuff into a folder. Red light. So we need some sort of animator controller for this. We'll call this our AI. Well, I guess we can use it for the player too, technically. Not too worried about the player at this moment in time. And we just need some animations in it. What does he need for animations? Well, he's going to need an idle, a move, and a death. Probably good for now. So we have idle, and we have, I don't know if we want to do a walk forward or a run forward, or even blend them both. Maybe we'll do a run, and then we just need a death. Okay. So what we really need here is just a couple parameters. We'll do trigger death, and we'll go from that state, in the any state, to here, to our death state, based on death. Idle to running and back. We're just I think we'll just do a bool. Is moving. I mean, you could also do like is, no, that's fine. Let's just go with that. Let's keep it simple. So is moving true and is moving false. No exit times. There we go. Plain and simple. So the easiest way to do it is to have the AI watch this thing itself. So for example, if this is going to be our statue, let's create an FSM on it. And we're going to have, say, get owner, and we're going to store a new global variable we'll call RedLight Manager. There we go. So now everybody can access him. So the best way to do this, that I find, is using two array lists. We have the players of the game, and we have the survivors of the game. So in this guy, if he has a state, we'll say here, and I'm going to name the state RedLight, and I'm going to make another state, and this one's going to be called GreenLight. So just states. So they don't even have any logic in them yet, just like that. So on our AI, if get FSM state, what if there's an FSM state switch? Oh, there is, or a test. Let's do the test. So we were talking of the RedLight manager. We'll have an we haven't named the FSM. Let's name it something we're going to remember. Something like, we'll say game. So now we're looking into the game FSM, and we're looking for example RedLight, and if true, we need to stop. Right? That can be every frame, and if we copy that, paste, and if it's green light, then we need to go. Simple as that. Let's get rid of that stop. There we go. So this is waiting for stop. I can even give it a fancy color. And this one's waiting to go. Right? We have waiting to stop, waiting to go. So if we, for example, say, if we're here and we're waiting for it to stop, once this hits stop, we don't want the AI just to stop instantly, because then the AI, is perfect. So what I like to do is random wait, and let's go something like maybe 0.5 to even 1 for a reaction time. All right, so we have this little delay now. This is kind of like the AI's reaction. So now we need to stop. So we need to figure out how we want the AI to move. So when I was doing this in 2D, and I was using physics. So to check if the player or anyone was moving, I was actually using the just the velocity. And we could do that here too. But there's tons of different ways. So we could turn around and say, okay, so if we're stopping, let's Animator bool. We need to actually physically stop ourselves, is moving as false, right? And we need to stop moving however we're going to be moving. So we could just be translating. Performance-wise, translating would be the easiest on performance, right? And then But I mean, like there's obviously some limits to that. So I don't know. Maybe we will use just some velocity. So let's make sure we have our collider and components set up. So we know it'll be something close to that, and we know we need a rigid body. On a rigid body, we're going to freeze the X and Z rotation so we don't just fall over. Oh, we can give them a bit of weight too, just because. Right, so here we have random weight, and then we're stopping, and we're going to tell the animator to stop moving. So one of the things we could do, actually, since we're going to use velocity, is not do this at all. Just go with a random weight and then go over here. And then from here, if we're waiting to go, again, we can have some reaction time, which doesn't necessarily affect the AI getting shot at this point in time, but it'll add a little, so it's not like go and then all of a sudden all the AI are moving perfectly and it seems a little robotic. But we say go, and we have a little bit of this reaction time, so the AI separate. It'll feel better. And when they go, then we do something. We go up like that, right? So we go into here, waiting to go and waiting to stop. So this controls nothing. It's just states doing this crossing, crisscrossing. So we need somehow to control the animator. So what are we going to do? I'm going to make another FSM here, and this one's going to be get speed every frame, and float compare. Now, actually, what would probably almost be better if we just take that speed and just stuff it right into here. That might be the easiest solution compared to doing a compare. Set animator float speed to speed every frame, and then from here, instead of the is moving, let's use the speeds. So if we're less than 0.2, sure, and if we're greater than 0.2, then we can get rid of our moving. We don't actually need it. We can just do that, right? And then he's set. So this is kind of our animator moving system, as simple as it is. Our rigid body, don't need to see that. So anyways, so that takes care of our animations and our logic to when we want to go and to stop. But now we need to actually physically go, right? So ultimately, we could run another system where we say here, set velocity. We can just stuff it in here, I guess. So set velocity as we come into here, every frame. We'll even do world, just because as long as we're going to build the map, like, okay, this is the Z, we're going, and we know where AI is going to go here. We know we're facing this way, and we want the AI to run this way, right? We want to keep things as simple as possible in that aspect. We don't need to be calculating angles and doing all sorts of crazy stuff, nav mesh stuff. We're just going to skip all that. We're going to be like, hey, we can do this without any of that. Right, so all we need to do is move on the Z, right? So we can do a velocity on the Z. Now, personally, I would like to add a little bit of randomness to it, right? So maybe we go, you know, from a 2 to a 2.5, and we'll call that our Z, and then that's what we're going to move to, is our Z. So every time we enter this, we'll just go a slightly different speed. And if we want, we can also add a slight difference on our X as well, so they actually kind of start moving a little off a bit to the sides. But I'm not going to worry about that right now. So now we're moving forward. Only we are not supposed to be moving forward in this one. We're supposed to be moving forward in this one. But we do want to set velocity in this one as well. Only what we'll do, other than just going, like, I mean, you could just go 0. Like oh, okay, stop. Right? But I think it would be better to interpolate it. I think that would also feel a little better. So interpolating from Z, from wherever the hell we are, to 0, and maybe over half a second, and store into Z. There we go. So let's set him as a start state for a minute, and let's go over here. And I'm going to turn him off for a brief minute. So the AI, if you can call it that, I mean, they're pretty simple. He is standing there, more or less, doing nothing. And if I go into the state on that thing, see how we had that little bit of wait time, and now he wants to move. Right now, if I could swap it over, then he would want to stop as well. So we'll have to build that bit of logic now. So the AI on this thing, our whatever the hell this thing is, our statue thing, said these things have no logic. Keep that in mind. There's very little logic in this thing so far. So when he goes, this thing, we need to get our owner. First thing, that's obviously a thing. What I would like to do would be I'm going to make it actually as a child of the plane. And I'm going to stuff it over here, roughly around there, give or take. And then I'm just going to test here. So I'm going to go, say, as far as -4, and as high as, obviously, 4, right? We have a range of 4. And this is going to be our start position. All right. So for this guy, he needs to do kind of one thing when it comes to the red light, green light. It's, let's start red light. Let's put down here, because we're going to have to put some logic in here after this. But so if we're on red light, what do we want to happen? Well, let's go random wait. You know, and maybe go 2 seconds to 3.5. I'll call that a finish. And then we can just go over to green light. Right? And then green light, we can come back and just come back over here. Right? Now, obviously, there's certain things we want to do in there, but just that simple logic, we should now see when he goes green light, this guy should start moving. Oh, we got to turn his FSM on. That would actually help, wouldn't it? I think it would. So he starts moving. He stops. He's moving, he stops. Right? It's just kind of that simple. His animator could actually use that walk state. It would help. I think this is a little slow. Maybe this one can go like that. And then let's get into the animator. Let's you know what? Let's give him a blend state. I think we'd all feel a little more comfortable with a blend state. Right? So in the blend state, we'll base it on speed and we'll add our motions. So let's go something like that. So we're idle at 0 velocity. We are walking at a velocity of 1. And we're running at a velocity of 5. Maybe 4. Okay. So in the animator, I guess we don't need these ones now. We can just use this one. That'll just make it look a little nicer too. And that'll be, like you'll see, make sure to turn his logic on. Not too sure why he's getting that little blip of speed there. Let's see. Okay, yep. There we go. So with this reaction time, technically he's still moving during this. That's the whole point of having this reaction time, is that he's not stopping right away. So let's make sure that we set the velocity in that reaction time, just on that side. We don't need it on this side, because on this side he's waiting to go. His velocity should be at this point in time 0. All right, and that'll fix that little blip he was doing there. Perfect. So in this guy, I think when we do the random, I'm going to go up a little higher. Something like that. So ideally now, if he gets to a certain point, he should be safe. So for example, this guy, we know his position going this direction is like 32, 33 on the Z. So what we're going to do is we're going to add, let's go over here. We'll put it in here. So let's put a state where we get position, the Z, and we need to float compare. Move that to the bottom. And if Z position is, well, if he's 33, if we're going this side of it, so we have to be greater than 33. If we're greater than 33, we're done the game. We have survived. If we're less, keep going. And if we're equal, we will keep going. Done the game and keep going. So we could do this on probably, where do we want to stick this? We kind of almost want it in between here. So if we are keep going, we can go to reaction, but if we're done the game, you know, we can go do something else. Stuff it in there. So for now, let's prefab our AI. Where is our RedLight GreenLight folder? There it is. And delete him. And ideally, what we want, I'm actually going to build a new FSM for this, is we're going to take in an integer, number of AI. We're going to take in a game object, which is the AI. We're going to take in a starting position, and we're going to take in a random range. We should almost call that X, and we're going to take in a random range Z. And what else do we want? That's probably good for now. So let's make these all inputs. Okay, so from the start, we now are going to do this. We are going to loop, and we're going to loop for the number of AI. So we need a loop event, and we need a done event. So loop and done. Done can go down here, and loop can go over here. So when we loop, we want to random float. We need 2 of those. And we want, actually, you know what? Do we have a range? That would be even better. On this one action just make life a little simpler. There's a nice little action called, let me find it, float compare range. No. Okay, well, whatever. So we need, well, let's do float operator. And because we really don't need to be doing that every single time, I'm gonna stick those over here. 2 float operators right at the start. And we're gonna take the random range Z, -1, multiply, and we'll call this random range Z negative. Take the random range X, multiply it by -1, and do random range X negative. So now we can do random range X negative by random range X, and we come out with a new variable. We'll call it X, and random range Z negative to random range Z, and call this one Z. There we go. And we need to get position, which this one we can actually do over here as well. No, let's keep it over here. Let's keep it over here for the starting position. So that's the start, or we'll call it starting position. And we want to now vector 3 add X, Y, Z. We want to add to the starting position our X and our Z. Okay, we'll finish a state. We'll just call that good. So this is our choose position state. So it chooses a position. Now it wants to create object. We want to create our AI. And put those to none. And we're going to create them at the starting position. So we need to store the created object. And now we can array list add. Move that to the bottom. So we're going to use players. But just type game object. We're going to add our created AI. There we go. So this is the create AI. Now we could at this point in time send the AI an event to tell them which game to play, like for when we do multiple games. For now, I'm just going to leave it like this. This is going to be universal for a lot of the different games that we can create, which is why we're building it this way. So now we have created the AI. We've added them to a list. I think that's actually probably pretty good. Actually, let's just do that. So once we're done looping for the number of AI, with this said, we'd still need to create the player. And I'd probably create the player probably just above this, or even just after this, I suppose. It really doesn't matter. We're going to finish this FSM, and then we're going to save this as create AI system. So now, get rid of him. So in the game, before we do this red light, green light, let's run an FSM that happens to be called create AI system. And this is our AI. Let's start with, say, 50 of them. Random range, let's give that, say, 2. And like I said, we checked that going this way, and that was 4. And our start position is him. And we're going to give this thing a finished event to red light. Okay. So we should now pop up with a whole bunch of guys. That all go here. So we need to control their direction, obviously. Or their rotations. So overall, things worked pretty good. I could have sworn, well, maybe it's because it was, no, it's not. Because here we are, it's the X, we have the 4, yeah, it was a 4. It just didn't seem like very much, so I'm going to double that. And up that one. So let's go into the AI real quick. Let's go into the Animator move. And let's smooth look at direction. Get velocity. So we're going to get our vector velocity, and then we're just going to look at our vector velocity. Well, more or less forever. All right, so that should look a little better. All right, it is looking better. See how they all don't quite start and stop exactly at the same time? They had a little bit of a difference to them, right? That kind of adds a little bit of a human factor to it, which is nice. The other thing is they're all part of this list, this is very important, this list. So the one thing that these guys need to do in their game, though, if they're done, we need, well, on a start state, we need to get owner. And we're just going to store it as ourselves so that we know how to talk to other scripts. So when we're done the game, all we're going to do is array list remove, and we want to array list add. So we're going to add ourselves to the RedLight manager players, or wait, no, not players, survivors, and we're going to add ourself. And then also on the RedLight manager, on the players, we want to remove ourselves. So we add ourselves to the survivors, but we remove ourselves from the players. We're no longer playing, we're a survivor. So the other FSM we're going to need, I'm also going to do this in a template, is when this thing goes, we need to loop, or no, we want to array list get next. So we're going to use the players, which I'm going to keep it on owner, but in reality, we could, actually I'll do it anyways. You could put it to the RedLight manager. It'll be the same thing. Yeah, I guess this is a little more flexible. So we have a loop event, and we have a done. Type game object. This is going to be the current player we're looking at. Loop and done. So when we loop, what are we going to do? We are going to get speed of, not ourselves, of the current player speed. Float compare that. And if current player speed is, we'll say, oh, not float operator. I was supposed to be a float compare. Why do I have an operator? Whoops. Whoopsie doodle. So if we are greater, we're going to kill the player. If we're less, we're just going to skip this guy. And if it's equal, then we'll still skip it. We'll be friendly. Skip and kill. So if we skip, we just go back. But if we kill them, we want to set animator trigger. You can also play like a bullet effect and sound effects and stuff. I don't have that. Well, I guess I do, but. So we want to set the trigger death on the current player. Array list remove, because we don't want them on our list anymore of the players, because we've just shot them. We don't care about them anymore. They're dead. And then that's pretty much about it. So let's save this for now. We might have to come back to this. I'll call it kill players. I'm gonna remove that. Come over here, and so when we go green light, when we come over and we hit red light, we are going to want to run FSM kill players. And I just thought of this, we're going to have to add a little something here. And it's just going to be a wait. Just a normal wait. I'll even use a variable here. We'll call this the delay. And we'll make sure the delay is a input. There we go. So now we can have a delay. So let's say, well, let's go with 0.7. No, let's go 1 for now. Let's see what happens at 1. So there's all our players. They all start moving. Comes over, it gets to 1 second, and it kills a bunch of people. Kill some more. Okay. So maybe let's take that delay up just a tiny bit. I don't want to go too high. Okay, so on our characters and our FSM here, more or less in here, we're going to have another FSM called killed. And when we get that, we'll make sure to set our velocity to 0. And that's in an FSM called FSM. So let's go back into game. Go back into our kill players. Oh, we never had our done. There we go. I'm going to put that in here. And we're just going to add that here. Send event to game object. I'm going to drag him in for references to the FSM killed. Make sure to swap them back to the current player. There we go. So now these guys' reaction time, keep that in mind. That the difference between that reaction time that we have, right, 0.5 to 1 for them to start stopping. And when he stops, it's also not instant. We have it interpolated down, right? And so we have to give him that 1 second delay. And we have to have kind of all that buffers, because a player, when the player's playing, the player isn't going to be perfect. Like, they aren't going to be like, oh, it says red light, I stopped like that millisecond. Like, it ain't going to happen. Like, the computer can do that. We don't want to see that happen, right? Jeez, are any of these guys going to make it to the end? Oh, geez. I'm going to put a wall or something there, I suppose, or something. So, let's look. So we have one guy left. This guy, who's right there, who apparently needs a helping hand because he's hitting the block. But we only have one person left that can be shot, and we have 7 survivors. Oh, and he got shot. I moved him. I killed him. That was my fault. There we go. So I think I'll just extend this out a bit. Yeah, I mean, put walls and borders up and all that. But there we have, we literally have the basis of the game happening. So really, the only thing left we have, if we want to know what ends the game, is after red light, we simply say players, the count, int compare. If the count is equal to 0, game over. If it's greater, keep playing. Or keep player, whatever. That's it. All right, so that's how we tell the game's over. So the player, on the other hand, the player is a little different, because the player needs to run the same logic in some aspects, anyways, of knowing when it's red light, green light, whether it's going to be visual or audio cues or whatever the case you have, and they need to be using velocity as well. They need to be using physics, or at least fake physics or something, I don't know. But they need to also play on these lists, and they need to have the events, right? They need to have that killed event. So a player, let's create, I'll just make a capsule for the player. I probably don't even need to do that. Let's create empty, put him there, give this guy a capsule collider 1.8.3. He could be our player. Which also means he needs a rigid body. Also with those same freezings. So he needs a mouse look. So, and for the player, I said, like, really you can build anything, whether you want to do a top-down point clicker, 3D, third person, first person, have no player. I don't know. There's a pile of different ways. I mean, it really doesn't matter. how you control your player. The only important thing is that we're going to move them in the same way, such as velocity, and have them in the player list. Right, so here we have mouse look, and let's get axis vector, and we'll, oh, this has to be relative to the camera, and then let's set velocity. Like that. Right, so that should give us a very crude, basic first person anyways. Yeah, that works fine. All right, let's give this a speed. No, I'm not worried about those. I know it looks ugly, but whatever. Whoops. So this could be our, for example, our player. So we need that same FSM though, where we have killed, right? So let's go over here. Back into here. There we go. So now I'm not going to know when the red light, green light actually happens. I mean, like I said, like you could, here. I suppose we should do something, right? Let's do an image. Let's go 2D, go to the game scene. If I don't do an image or don't do something, you guys are probably going to be like, what the hell? What's going on here? Just a very simple image. So the cube, when he is in red light, let's set graphic color of that to red. And when we're in green light, let's put it to green. Very simple. It'll sit there. I'm going to put this to scale with screen size. Mark him at the top. So player-wise, though, we need to prefab the player. And we need to delete our player. And then we need to come over to our cube. When we have our create system, we need to build our player as well. So say up here, let's create a player. So he needs to be an input. And all we want to do is choose a position. We might as well follow the same logic as the AI. And then we want to create. I guess we can pretty much copy that logic almost exactly. Only we don't want to create the AI, we want to create the player. Actually, you can create the AI, you can keep that same variable there, it's not going to matter. But he goes at that same position, and then we can go do our loop. That's it. So we need a new player here, so let's drag that in and hit play. Let's see what happens. So we're on red light. Oh, go out of the way. Oh, we need to put a velocity stopping thing for us, or friction or something. See, and if I keep moving, I guess I don't have a die animation to play. But we've been killed. We obviously didn't play it very well, and we got murdered. So here, actually, you know what? Let's do it with the physics material. That would only make life a little easier for everybody, I think. Create. Where are my physics materials? Rendering, playable, shaders, physics material. I'll just call it RedLight. And I'm going to give it to the player. I'll even give it to the AI. Come over here, and I'm going to take the ground. I'm going to give it to the ground too. Now, all we're going to say is static friction. Let's go like 0.25 and 0.25. Oh, it's supposed to be a... Well, yeah, we'll use the average. Let's go 0.4. Oh my god, not 4. Alright, so if we now hit play again, we should stop sliding at least. If not, maybe we can programmatically add it. So let's bring this up so we can actually see if we die. Or when we die, I should say. And this is where you have to kind of play with times. Oh my god, I got bumped and I'm moving. I go crazy. What's going on? Oh, you know what? That's right. With a capsule, because I'm in first person and I'm using whatchamacallit, you know, physics, freeze everything on the rotations, because your capsule typically doesn't move in the first person thing. Right, it's your camera that's moving, not your capsule. I'm going to move my thing up a little too high. See, if I keep moving though, oh, nope. Let's check it this time. We keep moving. Oh, we got shot there. Right, but that's all timing that you got to kind of play with on how reactive, you know, do you expect the players to be in your game and so forth. Now, when you do this system here, one of the things that I would do is, because this thing runs once and then it's done, when it gets done, personally, you want a next frame event and you want to run it again, just over and over, because we have a wait here. It runs so, like, it happens in that one frame. So when you first enter everything and it does its delay of 1.2 seconds, which we're going to bring that down a bit, it has this period of time. So by the time this thing runs and then it has to wait for the rest of this, technically a player, I mean, the AI is not going to do it, but the player can be like, okay, well, I've waited a bit of time and I know it's still in this state doing this wait, but he can start moving and it won't kill him until it re-enters the state. So by making this loop, if that player tries to screw around and move a bit, he's just going to get shot. We're just going to shoot him. We're not going to tolerate him stepping out of line like that, are we? No, fuck him. We're going to kill him. So let's see if we've improved our... Oh my god, I made it a little reactive. That 0.75 in the delay just... No, I think the AI, I should speed up the AI, because I mean, for me, like, look how long it kind of takes, right? Like it's a little long. So that's something like, okay, we should probably bring this. We've gone green light. It's doing all this stuff. Let's bring this down to like 0.5. But that also means we should help these guys out because they're all just gonna die. And it's not very nice. Right? So they're moving. They're waiting to stop. And we need a reaction time. So let's bring this down to like 0.25 and 0.65. Let's bring this also down. Oh, we'll just go the same, whatever. That part doesn't matter, but. And then the player would also need the logic that if they hit, that one position or beyond that position, that they're off the list as well for the game to actually end. I think I got murdered. So I can no longer look around. Vicious, vicious thing. Might have to up that delay a little bit. And we're on the outside. We're making a break for it. He's going. See, I can still stop. I mean, it's like you want it difficult, but you don't want it crazy hard either, right? See, I just started moving again. It killed me. So, I mean, AI need to be, I think, just a little quicker. But again, this is just kind of tweaking and dicking around and stuff, right? So they hit stop. I don't know, they're waiting for stop. So they're moving. They check the game. Oh yeah, they have that interplate, right? Over that 0.5 seconds. We need to bring that down as well, because that's being added onto this. So let's bring this down to like 0.15, 0.5. So at max, they have 0.5, 0.25, so 0.75 at max. Which is fine, because I mean, you want them to die sometimes, right? And his delay is 0.5. So there's a pretty solid chance they're going to die. And if I up that, but now that makes it easier for the player. Like I said, it's just kind of playing around with what works for you, for your game. Right, so there's killed some. No, I got killed. I got murdered. But there you go. That's kind of the basics of red light, green light, right? Without any of the fancy graphics. Now, adding in, like I said, sounds and bullets and shots and stuff like that. Like it's just a matter of stuffing that in here during this loop. Fire a gunshot sound or particle effects and stuff like that, and you put it right in here. During this you can run particles and sounds too for it going red light, green light, kind of like how I just did this little guy. There's tons of there you can do. But that's the basic premises of red light, green light. So like I said, now if you're going to make numerous games, right, different games, for me, one of the things is this is all on the start and stop. So I would go something like this, personally. We'll call it red light. And have this kind of go into here, and then not have this. bring him over here just in case. Have them both states, screw it. Right, so there's a red light game, and then really you could template this, and then we have just red light. So then it's you can use this same AI and just do different behaviors based on the game, right? Because now in here, when we create the AI, after we've created the AI, we just send an event. Now it's playing red light. Now, technically, nothing changed there, except for the fact that if we were in a different scene playing a different game, you could give it a different event, and it would still work, right? Because they're still playing the game, they're still moving, right? Because they all got that event red light. This is the game we're playing. So anyways, I'll save it and call it good there.